All right, guys, so I'm going to go over Lab 4, Visible Color, RGB. We're going to be studying all light, but all colored light. But for this lab, at one point, we focus on red, green, and blue, just because those are the only colors of light our eyes can see. And that's because we have things called cones, and different animals have different colors, but for us, we have a red, green, and blue one. So when that color light hits our eye, it makes it it like basically like interacts with it and entices it so that then it like basically like gives it a little bit of a shock so that you see that color. First part of the lab, we're using the first half of the simulator, and your goal was to try and create this light, these colors of light. So the first one was green. So you had to try and get the girl to see green light. Easiest way to do that, just turn the green light on. The next one was blue. Again, pretty simple. Just turning on the blue light. Now purple. It's just like what we think. Blue plus red makes, that's a little pink. I'll turn the red down a bit. Makes purple. And with light is a little different than paint. Light is a particle, just like paint, but paint isn't also a wave. Light is also made up of particles and waves. And it's all about focusing on the mixing of those waves, and more likely it's frequency. And different colors have different frequencies. And this is a good example. Red has a low frequency. The waves are farther apart, it moves slower, and there's fewer waves. And then as you move up, the waves get closer and closer together, increasing the frequency. You get more and more waves. They get tighter and they move faster. So red's really slow, while purple or violet is the fastest. So then to make purple, you mix blue and red light together. And basically what it does is, by adding these two together, it speeds up the blue wave to make it purple. So you just add a little bit more energy by adding the red in here, which makes this wave go faster and moves it up to purple. So the next one we're making is yellow. So yellow you're going to use red and green. And if you were to mix paint, mixing red and green together would give you like gross brown. However, in light, it makes yellow because if you're adding red to the green, it kind of slows the green down and moves it to yellow. Or you can think about it the opposite way. You're adding green to red, which increases the energy of red and pushes it up to yellow, because it makes the green, which has a higher frequency and is moving faster, speeds up the red light and makes it yellow. So you can either think of it as the red slows down the green, or the green speeds up the red to yellow. The next color we had was orange. Orange, you're just going to turn down the green a bit. Same thing as the last one. Black. Black is the tricky one. We have to kind of think back to Monday when we talked about light and absorption. Black is the absence of light, meaning all the colors are absorbed by it and none are reflected back to your eye. So there's no light. Meaning, so like when it gets dark at night and you start that you can't see, it's because there's no light. So there's no way for you to see color if there's no white light at all. And then the opposite is white light, which is all the colors mixed together, which then makes white light, which is made from the sun and light bulbs and like fire. However, let's say then the sun sets, and there's no light, you're not going to see anything because there's no way to get any color. There's no way for the white light to bounce off anything. All right. The second part, we're focusing on the other half of the simulator, and all you have to do is write your observations. So I'm going to show you the main concept of what I wanted to get wanted you to get out of this lab, well, this section of the lab. We're going to go back to the simulator. We're going to do the second half. So we have a flashlight, and we can change the color of the flashlight. I'm going to make the flashlight yellow. We can see the yellow particles hitting her eye. And then we're going to put a filter up in front of it, and I'm going to make the filter red. And what I want you to notice is that as the yellow light is hitting the filter, the red filter, none of it is going through. And that's because the red filter is absorbing all the yellow light. And it'll do that for all the other colors as well. The only way light can go through this is if I make the light red, because the filter will no longer absorb this because it's matching the frequency of the red light. Meaning it's matching the wavelength and frequency of the red light that's coming through. And now if I change it, let's say to purple, which has a much higher frequency than the red, it can't get through that filter, only if I match it up with that red color. Now you can even see this even better if I change the flashlight to white light. So I have all the colors mixed together to make white light, but still only the red is going through because of the red filter. All the other colors are getting absorbed. If I change it to yellow, only the yellow will go through. Green, only the green. Blue, only the blue. And purple, only the purple. That's because every other color is getting absorbed except the purple, because it's matching its high frequency. It's matching this crazy purple frequency. And that's what I want you to focus on and to learn from this. So this is what you're going to write for your observations and your conclusion, is that we see different colors, and colors are different because they have different frequencies. And the only way you can manipulate these by adding colors together and adding the frequencies together to change the frequency to a new color, or you can block it by adding different colored filters in front of it and only letting certain ones transmit or go through the filter. All right? The other colors then get absorbed. All righty, I hope that helps you.